In this section of 7.3, where we are kind of introduced to the idea of the projection of one vector along another vector, which we'll dive more into in section 7.4. But in this section, we're introduced to it so we can start thinking about how to apply trigonometry to this situation. So, here we're asked to find vectors P and Q to form this angle that's 52 degrees. And we're asked to find the vector R. So R is this little pink guy that points in the direction of Q, but his length is only what's called the projection of P along Q. So I kind of like to think of it as the shadow of P when it's forming that right angle with Q. So R gives us the length, and Q gives us, I should say P, the shadow of P, which gives us the length, and Q gives us the direction. So we learned in the previous problem sets that the unit vector for Q gives us the direction of Q, but its magnitude is only 1. So I'm going to call it kind of 1, right? Its scalar would be the value of 1, but it gives us the direction of Q. And the magnitude of R tells us how long that shadow is. It doesn't have anything about direction. It just tells us how long that pink line is, that shadow from P. So actually, I'm sorry. Yeah, that's right, because we don't want all of P, we just want the shadow. So we're looking at the magnitude of R, the pink line. In fact, I think I'll do that in pink. So the vector we're trying to define is this one, which is given by the length, the magnitude of that pink length, which is the shadow of P, and the direction of Q. So let's see, what should we call this? So this is the projection of P onto Q. Okay, so let's find those things that we need. So first of all, how do we find the unit vector for Q? Because we need that right here. So to find the unit vector, we take Q, which is, and we divide it by, so the unit vector, I'll call it U, is Q, the vector Q, divided by the magnitude of Q. That should be a straight line. Okay, so the magnitude of Q is square root of 10 squared plus 4 squared, which gives me 100 plus 16, which gives me 116. That one is not a perfect square root, but I can break it down. It's a factor of 4, and I can get, there's 25 4s and 100 plus another 4 and 16, so that's 29. So that breaks out, the 4 comes out as a 2 squared, so 2 radical 29, so that breaks down like that. So that's my magnitude of Q. So to get the unit vector, I take each component of Q and divide it by that magnitude. So that's 10 divided by the magnitude. So that's 10 divided by 2 radical 29. And for the second, the vertical component, I get 4 divided by that magnitude. So 4 divided by 2 radical 29. I get my pointy bracket, and I'll simplify that. 10 divided by 2 gives me 5 over radical 29. I'm going to go ahead and leave it in unrationalized form, though, because I'm going to do some more math to it, so there's no point in rationalizing it at this point. All right, going on to, okay, so I have this part now. In fact, I will kind of highlight it here. Let's go with the blue highlighter. So the unit vector for Q is this. I still need to find the length. So I now have the direction of Q, but its length is only 1. So it's kind of like it's this little thing, whatever the length of 1 would be. But I want to go the whole length of R, so I got to find out what is the length of R and multiply it by that unit vector. So let's do that one. Let's do it in orange. It's a little easier to see than red. And I don't really have a good pink. The pinks are really hard to see. Okay, so to get R, I get, how do we get that? So I'm going to erase over here so I can see a little better. This, we got to think of our SOHCAHTOA. R is really the adjacent. And we can get P, the length of P, by finding the magnitude of P. So thinking in SOHCAHTOA, I have I want the adjacent and I have the hypotenuse. So adjacent and hypotenuse gives me cosine. So I get cosine of 52 degrees equals the magnitude of R, that's the adjacent side, divided by the magnitude of P, which is the hypotenuse. So to solve for this guy, I just solve this thing, and I get I gotta need a P in front of there. The magnitude of P times cosine of 52 degrees. So I need to find P. So I'm going to change colors here. I don't like that color. So for P, I have the vector is 2, 7. So to find its magnitude, I could say 2 squared plus 7 squared gives me square root of 4 plus 49, or square root of 53, which is prime. So that is my P. Plugging that back into here, I get that the magnitude of R is radical 53 times cosine of 52. That's an exact answer. I'm going to use my calculator to get an estimated answer. So we'll do that. I'm kind of on the fence if I want to do that or not, or wait till the end. I guess it's user choice. So I'm going to, though. Square root of 53 times cosine of 52 degrees. My calculator's in degree mode, and I get approximately 4.48. But I'm not quite done. Now I have my unit vector, and now I have my length. So I'm going to highlight that one. And I don't know. Let's do a pink. So this thing I represent there. So now I got to put these two things together to get that projection, that length of R. That vector R. So R equals the length of R, which we estimated to be 4.48 times the direction of Q, which is 5 radical 29. That's the unit vector of Q. So that's almost done. I can take that one step further if I have a calculator, which you will in this unit. So I will take that into my calculator and get 4.48 times 5. So I'm multiplying the constant 4.48, the scalar, times each component to get my new component. So it ends up being equal to just a vector, so 2 pointy parentheses and a comma. So if that horizontal vector, I take the 4.48 times 5 divided by the square root of 29. So multiplying the scalar by component, the a, and I get 4.16. And for the vertical component, I have 4.48 times 4 divided by square root of 29. I did earlier, was kind of hesitant if I wanted to find that 4.48 or just leave it in exact form, because I could have put that in the calculator here instead of earlier. You know what? I have an error here. I'm so sorry. Let's back up. Alright. I have to back up quite a ways. I'm sorry. So this thing should have been a 2 when I reduced. And that makes this thing a 2, which makes this thing .48 times 2 divided by square root of 29. So I was off by a factor of 2 there because I did not reduce my my numerator correctly. So there we go. There's my final answer. I'm going to shrink this in so I can see the whole problem.